Dinosaurs Uncovered, Size, Behavior, and Anatomy. Introduction: Entering the Lost World. Dinosaurs are among the most fascinating creatures to have ever walked the Earth. Their sheer size, unique behaviors, complex social structures, and extraordinary anatomy captivate the imagination of millions. But beyond the roaring beasts portrayed in movies, dinosaurs were a diverse group of animals with intricate ways of living. In this video, we'll dive deep into their physical dimensions, explore how they might have courted and mated, investigate their group behaviors, and unravel the secrets of their skeletal and muscular systems. Get ready to embark on an unforgettable journey through the hidden life of these prehistoric giants. Chapter 1. How big were dinosaurs? The size of dinosaurs varied immensely, from tiny chicken-sized creatures to towering giants that could rival modern skyscrapers. Some of the smallest dinosaurs, like the agile Compsognathus, were no bigger than a domestic cat, while the largest sauropods stretched to astonishing lengths. Imagine an animal whose neck alone could extend across a tennis court and whose total height could make standing next to a giraffe feel like looking up at a small shrub. Their weight was equally impressive, with some species tipping the scales at over 70 tons. But size wasn't just about intimidation, it also played a vital role in their survival strategies, allowing them to reach high vegetation, intimidate predators, and regulate their body temperatures through sheer mass. Chapter 2. The mysterious rituals of dinosaur courtship. When it comes to courtship, dinosaurs likely engaged in elaborate behaviors to attract mates. Although we can only infer these behaviors from fossil evidence and comparisons with modern-day birds and reptiles, there are fascinating clues. Some species had ornate crests, frills, or horns that might have been used in visual displays during mating rituals. Think of a dinosaur with a bright, colorful frill fanning out to impress a potential partner, or a male engaging in rhythmic movements to demonstrate strength and vitality. In some cases, fossilized nesting sites suggest that certain species return to the same areas year after year to breed and raise their young. Eggs found in organized clutches reveal the possibility of communal nesting grounds, much like modern seabirds. This hints at complex social dynamics and parental investment, making the reproductive lives of dinosaurs more sophisticated than once imagined. Chapter 3. Living Together, Dinosaurs and Group Behavior. Dinosaurs were not just solitary wanderers. Many species exhibited strong tendencies to live and move in groups. Fossilized trackways show multiple individuals walking side by side, indicating coordinated herd movement. For herbivores, such as the hadrosaurs and ceratopsians, living in herds provided safety in numbers, making it harder for predators to single out a vulnerable target. These herds could range from small family groups to vast congregations that migrated across long distances in search of food and water. Predatory dinosaurs, traditionally thought of as lone hunters, may also have exhibited pack behavior in certain species. Fossil evidence suggests that some theropods, like certain raptors, hunted cooperatively, using tactics that maximize their collective hunting efficiency. Living in groups required complex communication, possibly through vocalizations, visual signals, or even scent marking, allowing these creatures to coordinate their movements, protect their young, and maintain social bonds. Chapter 4. The incredible structure of dinosaur bones. Dinosaur bones were marvels of evolutionary engineering, perfectly designed to support their massive bodies and dynamic lifestyles. Unlike the dense bones of many modern reptiles, many dinosaurs had a unique skeletal structure featuring hollow cavities within their bones. This adaptation, known as pneumaticity, reduced the overall weight of their skeletons without compromising strength. For gigantic sauropods, such an adaptation was crucial to allow their long necks and tails to remain mobile yet structurally sound. Furthermore, bone texture and growth rings provide clues about their rates of growth and metabolism. Some species grew rapidly, reaching near adult sizes within a few years. This rapid growth is indicated by the presence of fibrolamellar bone, a type of tissue associated with fast-growing animals. The joints and limb structures of dinosaurs also reveal a highly active lifestyle, with many species capable of running, climbing, or even swimming, depending on their ecological niche. Chapter 5. The muscular powerhouse beneath the skin. Underneath their scaly skin or feathered coats, dinosaurs possessed powerful muscular systems that enabled a wide range of movements. Their musculature was intricately connected to their skeletal structure, allowing for feats of strength and agility. Theropods, the bipedal carnivores, had exceptionally strong leg muscles, enabling them to sprint at remarkable speeds. Their robust tail muscles provided balance and additional propulsion, making them deadly pursuers. On the other hand, the massive herbivores required powerful limb muscles to support their enormous bodies and move steadily across vast landscapes. In species with specialized adaptations like the ankylosaurs, muscles around the tail and back supported defensive structures such as clubs or armored plates. Recent studies have even suggested that some dinosaurs could perform complex bird-like movements, using their muscles to maneuver wings for display, thermoregulation, or even primitive flight in smaller species. The muscular anatomy of dinosaurs reveals a group of animals exquisitely adapted to their environments through strength, precision, and endurance. Chapter 6. How dinosaurs communicated and coordinated in groups. Social living among dinosaurs demanded effective communication, and there are multiple indications that they developed sophisticated methods to convey information within groups. The physical adaptations of some species hint at visual signaling. For instance, the elaborate frills of ceratopsians or the striking crests of hadrosaurs. These features could have served as visual identifiers, helping members of the same species recognize each other or signal dominance within the group. Vocal communication is another strong possibility, especially considering that modern birds, descendants of theropod dinosaurs, use complex calls and songs for social interaction. The structure of certain dinosaur skulls, particularly in species like the Parasaurolophus with its elongated nasal crest, suggests that they could produce deep, resonant sounds capable of traveling long distances. This would have been invaluable for coordinating herd movements or alerting others to potential threats. Body language, such as posturing, tail flicking, or wing-like arm movements, could also have played a role in nonverbal communication, enabling quick and effective coordination. Chapter 7. Parenting and the care of young dinosaurs. Contrary to the outdated notion that dinosaurs laid their eggs and abandoned them, there is significant fossil evidence suggesting that many species engaged in parental care. Fossilized nests show that some dinosaurs meticulously arranged their eggs, possibly covering them with vegetation to regulate temperature, much like modern birds or reptiles do. In some species, adults are found fossilized in positions that suggest they were brooding or guarding their nests. This level of care indicates that at least some dinosaurs invested considerable time and effort in raising their offspring. Juvenile skeletons often exhibit different proportions compared to adults, such as larger eyes or shorter snouts, features typically associated with species that require prolonged parental care. This suggests that young dinosaurs might have remained with their parents for extended periods, learning survival skills and benefiting from the protection of the group until they were large enough to fend for themselves. Chapter 8. Defense mechanisms and survival strategies. Dinosaurs evolved a remarkable array of defensive adaptations to survive in their often dangerous ecosystems. Herbivorous species frequently develop physical traits designed to deter predators. The armored ankylosaurs, for example, were covered in bony plates and wielded a formidable tail club capable of delivering devastating blows, ceratopsians sported massive frills and intimidating horns that could be used in defense or combat with rivals. Meanwhile, hadrosaurs relied on keen senses and herd behavior to detect and evade predators swiftly. Carnivorous dinosaurs, though often seen as apex predators, also needed defensive strategies to protect their territories and young from rivals and other threats. Speed, agility, and sometimes cooperative defense in packs helped them maintain dominance. Camouflage through coloration and patterns may also have played a crucial role in both predator evasion and ambush hunting, though direct evidence for dinosaur coloration is limited to certain fossilized pigments. Chapter 9. The Legacy of Dinosaurs in Modern Animals. While the non-avian dinosaurs are no longer with us, their legacy continues through their closest living relatives, birds. The evolutionary connection between birds and dinosaurs is supported by numerous anatomical similarities, including hollow bones, similar lung structures, and nesting behaviors. Certain theropod dinosaurs had feathers, likely used for insulation, display, and in some cases gliding or flight. The discovery of feathered dinosaur fossils revolutionized our understanding of their biology, blurring the line between traditional reptiles and modern birds. Today, S-birds exhibit many behaviors once thought unique to avians, but now recognized as having dinosaurian roots, such as complex vocal communication, parental care, and sophisticated social structures. Thus, every time we watch a bird take flight or hear its song, we are witnessing a living legacy of the dinosaur lineage, a reminder that these magnificent creatures are not entirely lost to time. Conclusion. The timeless fascination with dinosaurs. Dinosaurs continue to captivate our curiosity, not just because of their immense size and power, but because of the complex, dynamic lives they led. From their towering skeletons to their intricate social behaviors, from their powerful muscles to their sophisticated communication systems, dinosaurs were far more than prehistoric monsters. They were vibrant, diverse animals that adapted in extraordinary ways to their environments. As science advances, we uncover more about their lives, shattering old myths and revealing new insights. If you enjoyed this deep dive into the hidden world of dinosaurs, make sure to like this video, subscribe to the channel, and hit the notification bell so you won't miss our next exploration into the wonders of natural history. Share your thoughts in the comments below. What fascinates you the most about dinosaurs? Let us know.